3.1, solve one-step equations. So a couple definitions here. Inverse operations are operations that undo each other. For example, addition and subtraction. And then equivalent equations are equations that have the same solutions. Also, I don't remember if I've shown you this before, but if I write like SOLN or SOLNS, that just means solutions. It's just a short way to write it. So we're going to have a couple properties that we'll be using along the way. So first we have the addition property of equality. So it says that if x minus a is equal to b, then x minus a plus a is equal to b plus a, or x is equal to b plus a. So essentially whatever you do to one side, you have to do to the other. So if we want to move something over to like get something by itself, we have to undo it by doing the inverse operation to move it to the other side. Then we have the subtraction property of equality. So this one, it's going to look very similar to the one I just did, but if x plus a equals b, then x plus a minus a equals b minus a, or x equals b minus a. Then we have the multiplication property of equality. This one says if x over a, so x divided by a, equals b, and a is not equal to 0, okay, because we cannot have a 0 in the denominator. Okay, it's never allowed to happen. Then a times x over a equals b, or let me do it this way, equals a times b, or x equals a times b. And then the opposite of that is the division property of equality. Which says that if a times x equals b, and a is not equal to 0, which you'll see why that has to be the case in a second. Whoa. Then a times x divided by a, so over a, equals b over a, or x equals b over a. So I know it looks a little confusing because that's basically all letters right now, but when we do it with numbers, you're going to have like a variable like x, y, w, t, something like that. And then you're going to have numbers. So it's you want to do something to get the letter on one side and the numbers all on the other side. Okay, typically we want the letters on the left and the numbers on the right, but that doesn't have to be that way. So these are going to be one step to get from letters and numbers on the same side to just a letter on one side and just numbers on the other side. So I'm going to do a few examples out of the little guided practice thing. So the guided practice examples. And I actually have a little flashcard game, which I have the 2-step equation, so that'll be the next section, but I have a 1-step one. I just forgot it at home. I thought that was the one that was here, but anyways, it wasn't. So one day next week we'll have like a game day and we'll do like the equations and stuff. I'll like put them up and I don't know, have a little competition, I don't know, something like that. We'll make it fun. So the first one is y plus 7 equals 10. So I'm going to actually write it a little bit different than how it's written up here, just because I think it makes it easier and it's the way that you'll see pretty much everybody else do it any time after this. So we need to get y by itself. Okay, so what we do is we have to undo whatever's being done to this. So this is positive, so to get rid of it, I need to subtract it. So we write minus 7, and whatever you do on one side of the equal sign, you have to do on the other side. Have you seen this before?
Yeah.
Okay.
I remember.
So then on the left side where we have them opposites, they cancel. So you're left with y equals 10 minus 7, which is 3. Number 2, x minus 5 equals 3. So I've got subtraction here, so its opposite is addition, so I'm going to add 5 to both sides. So my negative 5 and positive 5 cancel on the left. It leaves you with x equals 3 plus 5 is 8, so x equals 8. All right, on the next one, I'm going to let y'all tell me what to do. Q minus 11 equals negative 5. So what do I need to do to both sides of this one?
Add the 11 to the 5 and 11.
Yep. And then what does that leave me with?
6.
Yep. Q equals 6. Yep, because 11 minus 5 basically is 6. All right, this next one. So like I said, normally we do letters on the left, numbers on the right. It's just the way that it always gets read off. Doesn't have to be that way, though. If the numbers are on the left side and the letters are on the right, it's totally fine. So number 4, we have 6 equals t minus 2. So what do I need to do to this one?
You need to get rid of a 2.
What did you say, Kalia? I think you were right. That's why. Yeah, that was right.
Wait.
That's why I just couldn't tell. I thought you said +2, but then I was like, wait a second, is that what you said?
Yeah, I was like, wait.
So yes, we add 2 to both sides still. So then those 2's cancel. So then you're left with 6 plus 2 is 8. So 8 equals t. So that's a few addition and subtraction. So then let's look at a few multiplication and division ones. So number 5, we have 4x equals 48. So currently I have 4 times x equals 48. So if I want to get rid of it, the opposite of multiplication is division. So I'm going to divide both sides by 4. So then in terms of the division, the 4's cancel. So that leaves you with x on the left equals 48 divided by 4, which is 12. Forgot to box. What is going on? Trying to box my other answers and it kept going crooked. Let's see, number 6. -65 equals -5y. So what do I need to do with this one?
Divide the 5 into 65.
Yep, and make sure you do the negative with it. So divided by -5. So the -5's on the right with the y cancels. So on the right side I'm left with a y. -65 divided by -5 would be what?
13.
Mm-hmm. Yep, 13, and negative divided by negative is positive, so it's positive 13. All right, number 7, 6w equals -54. So what about this one?
Dividing 6 into 54.
Yep, so divide by 6. So on the left, my 6's cancel. Leaves you with w equals, what's -54 divided by 6?
9.
And is it positive or negative?
It's negative.
Yep. All right, let's see, one more multiplication one. Number 8, 24 equals -8n. So what do I do to this one? Yep, divide by -8 on both sides. So -8's cancel on the right. Leaves you with n on the right. And then 24 divided by -8 is
3.
positive or negative?
Positive. Oh, negative.
Negative. Yep, -3. All right, now some division, well, I say division ones that start with division, so we need to use multiplication to undo it. Number 9, got t divided by -3 equals 9. So to get this by itself, okay, it's being divided. So I need to multiply to undo it. So I'm going to multiply both sides by -3. So on the left, my -3 cancel. So I'm left with t equals 9 times -3, which is -27. Let's see, number 10, 6 equals c divided by 7. So what would I need to do with this one?
You need to get the 7, multiply the 7 together, and then put the 7 over time, multiply the 7 times 6.
Yep. So we multiply both sides by 7. So on the right, my 7's cancel. It leaves you with a c. And then 7 times 6 is what?
42.
Yep. Let's see. Number 11. 13 equals z divided by -2. Yep, multiply by -2. And on the right, they're canceling. And then what do I have? So what's -2 times 13?
6. Well, 26.
And is it positive or negative?
It's negative.
Ah, what is happening? This thing is like spazzing out on me. It's been doing that all day. -26 equals z. And then number 12, a divided by 5 equals -11. So what do I do for this one? Times 5 on both sides. Fives on the left cross out. Leaves you with a. And then -11 times 5 is?
55.
Yep, -55. So the other part of this section that goes with this is that once you get an answer, you can plug it back in, okay, for that variable, and the two sides have to be equal. Okay, so it's a way to check your work and make sure you did it right. So when we go do some of the ones out of the homework, we'll actually check them. I may or may not require you to check them on the quiz or the test, but it's always good to check them regardless if I do or not, because then guarantee you got the answer right. Never a question about it. So, out of the normal homework problems, exercise or examples, that was all the guided practice ones. The first ones are going to be addition and subtraction, and then they want us to check. So we are going to do the check part for these ones. So number 4, we have m plus 9 equals 2. So what do I need to do to this one? Yep. Then what?
2 subtracted by -9 is -7.
Yep. So m equals -7. And then they want us to check. So we take -7 and we plug it in for m. So I'm going to replace m with -7. So -7 plus 9 equals 2. So -7 plus 9 is what? Or 9 minus 7 is?
2.
2. So 2 equals 2. So that means that it was right.
I don't know why this is taking so long.
Let's see, number 6. 13 equals 7 plus z. So what do I need to do with this one?
Subtract 7 and then 7 into 13. Get rid of the 7. And then it's -6.
So 13 minus 7. Your number's right, but what sign is on it?
Positive.
Yep. So 13 is bigger, and since it's positive, it's positive. So 6 equals z. So then to check, we plug it in for z. So we get 13 is equal to 7 plus 6. So what is 7 plus 6? 13. So 13 equals 13. So that means it's right. All right, number 8. -3 equals 5 plus a. So what should I do here? Yep, subtract 5 on both sides. Those cancel. So you're left with a on the right, and then -3 minus 5 is what? -8. Then we check by plugging in -8 for a. -3 equals 5 plus -8. So what is that? -3 equals -3. So that one's good. Number 10, t minus 5 equals 7. So what do I do with this one? Plus 5. Yep, 5's on the left, cancel. So you're left with t equals 7 plus 5. 12. And then check by plugging 12 in for t. So 12 minus 5 equals 7. 12 minus 5 is 7. 7 equals 7. How do we feel about addition and subtraction? Feel okay with those? All right. I'm gonna move on to multiplication and division then. Let's see. Number 18. So these still say solve and then check. So we'll do that as well with these ones. So number 18, I've got -4 times Q equals 52. So what do I do with this? Yep, divide -4 on both sides. -4's both cancel, so that leaves you with Q equals 52 divided by -4.
16.
You have a few too many.
Oh, 3. 13.
Yes.
Yeah.
And it's going to be positive or negative?
Negative.
Negative. So then we check it. So now I'm plugging in -13 for Q. So -4 times -13 equals 52. So -4 times -13 is,
52.
yep, 52 equals 52. Number 20, -108 equals 9J. Divide 9 on both sides. 9's on the right, cancel. So you get J on the right side, and then what's -108 divided by 9?
12.
Yep. And then positive or negative? -12. So then check. We have -108 equals 9 times -12. 9 times -12 is?
100.
Yep. And it's negative. So -108 equals -108. (22) 187 is equal to -17 times R. We'll do it this one. Yep, divide by -17. Then they cancel. Leaves you with an R on the right. Then 187 divided by -17.
11.
Positive or negative?
Negative.
Yep. And then check. 187 equals -17 times -11. -17 times -11 is,
57.
so 187 equals 187. Then 24. M divided by 2 equals 14. So what do I do with this one? Yep, multiply by 2 on both sides. So, yep, the ones on the left cancel, leaves you with M on the left, equals 14 times 2 is 28. So then to check it, we have 28 divided by 2 equals 14. 28 divided by 2 is
14.
Yep. 14 equals 14, so that one's good. 26. 7 equals t divided by negative 7. So I do this one. Yep. Multiply by negative 7. Ones on the right are canceling. Leaves you a t on the right. So negative 7 times 7 is?
Negative 49.
Negative 49. And to check it, you've got 7 equals negative 49 divided by negative 7. Negative 49 divided by negative 7 would be?
7.
So 7 equals 7. Sounds good. And then the last one for today, number 28. Negative 3 equals d divided by 14. Divide by 14. Because this is a negative, I'm going to put that one in parentheses too, so I remember that I'm multiplying and not subtracting. So on the right, 14's cancel, so that leaves you with a d. 14 times negative 3 is?
Negative 42.
Negative 42. And then to check it, we've got negative 3 equals negative 42 divided by 14. Negative 42 divided by 14 is?
3.
Positive or negative?
Negative.
Yep, so negative 3 equals negative 3. Sounds good. Any questions about any of these? Alright, I am going to have you do (3 through 27 odd). Yeah, lots of practice with this because the next section, the next section is two-step equations, so it'll be two things that we have to do. So it'll combine like two of these steps that we're doing in this section to solve the problem.